So trigonometric ratios. Okay, so in any right angle triangle, the trig ratios only work if there's a 90-degree angle in the triangle. Okay, the sides can be referred to with respect to a given or indicated angle. Okay, the angle can sometimes be, or is often called the angle of reference. And it could be named a Greek letter or colored in. Okay, or referenced by its vertex. So by that it means like angle C. Angle C would be where that 90-degree is in that first picture there, right? And so we can call the triangle itself triangle ABC. And you can see a little theta. I know it's not the clearest, but that's a little theta, right? Or angle A is the indicated angle. So what we're going to do is we're going to stand at angle A where theta is, and I'm going to label the triangle accordingly. Okay? One is always true about a right angle triangle. Don't?
The other 2 points add up to 90, or other 2 angles?
Yeah. Well, it doesn't have to be a right angle triangle. That rule applies to all triangles, that the sum of the angles, interior angles, adds to 180. So that rule just applies to all triangles, not specifically to right angles. Maybe didn't ask the best question in the world, but like the side lengths, one of them never changes with a right angle triangle. Which one is that? Ricky?
The hypotenuse?
The hypotenuse, right? So, and that's the longest one, right? And that's always, or with Pythagorean theorem, we always call it C, side length C, right? So you'll notice these are the capital letters. So the capital letters are going to denote the angles, and then the lowercase letters are going to denote the side lengths, right? And so we know that the hypotenuse is always going to be the biggest one in a right angle triangle. So this is always going to be hypotenuse. So we're okay with that? Now the other two are the ones that are up for debate, and it depends on which angle you're standing at. Because I'm standing at angle A, I'm going to stand at angle A, and I'm going to look across from me. Do you know another word for across is? Opposite. Okay, so you're standing at angle A and you look directly across from you. That's what we're going to call the opposite side length. By default, there's only 3 side lengths in the triangle. What's the last one? Adjacent. What's another word for adjacent? Beside. So if you're standing here at this angle, the one that is beside you is what we're going to call as adjacent. There, okay? So again, we're just going to stand here. Okay, this is going to be opposite, adjacent, and hypotenuse. So we're okay? So we had this acronym, right? Does anybody know what the acronym is for right angle triangles that represent the trig ratios still? SOHCAHTOA. Okay, and I've seen SOHCAHTOA written a few different ways, depending on who you've come from and where you've seen it. I've seen it written like this. This is the way I had seen it in the past. Everyone agree? We've seen that before? Okay, what it says is opposite and hypotenuse. When I take the ratio of the opposite and the hypotenuse, I can compare that with sine. And then adjacent and hypotenuse, the ratio of those, I can use it with cosine. And opposite and adjacent, I can use it with tan. Right? And these are just ratios. What's another word for a ratio? Say that again, Esme? Equal bars. There'd be like almost like a ratio is going to be like a fraction, right? Is that what I mean? That's what's kind of maybe not the best question, but a ratio is a fraction. A fraction of what? Or a comparison would be another way. It'd be a comparison of the opposite relative to the hypotenuse, right? And so another way to write SOHCAHTOA, if this helps some of us, would be to go Okay. So sine is going to be the opposite over hypotenuse. That's what's depicted in this little table here. Okay, the ones you have not seen are the reciprocal trig ratios, which I'll bring to your attention in a sec. We're just really concentrating on the grade 10 stuff that we see right here, right now, right? So sine, if we follow our SOHCAHTOA rule, we're going to see sine is the opposite side length divided by the hypotenuse. And cosine is going to be the adjacent side length divided by the hypotenuse. And tangent is going to be opposite over adjacent. Everybody good with that? Now, if I ask you the question of what does the reciprocal mean to you, what does it mean to you? We've dealt with it a number of times in this course already.
How many times a line intersects?
Mm-mm.
Doesn't
What are
sound
you thinking of? What are you thinking of?
like discriminant.
Oh, yeah. No, the reciprocal. What's a reciprocal?
Inverse.
The inverse. Like you're flipping, right? You're flipping what? A fraction. So the problem is, I don't really see a fraction here, but we can always create a fraction by doing what? Well, you could flip it, but I guess my point is that we can always divide by 1.
You can always divide by 1.
So you divide by 1, that's what I've written here, right? And so the reciprocal trig ratios are just 1 over the original ratio of sine, right? You're just flipping these two. Can we see that? So the hard part is going to be remembering these names. One of them's easy to remember. It's cotangent. Cotangent is the reciprocal trig ratio to tangent. What's it mean? Instead of tangent over 1, cotangent is going to be 1 over tangent. Okay, which subsequently also flips the original ratio of opposite over hypotenuse. So cosecant, CSC, is hypotenuse over opposite. You'll notice that is the reciprocal of sine theta, where it was opposite over hypotenuse. So we see that? So it means to be a reciprocal trig ratio, which these are all fancy words for just take the fraction and make it reciprocated, if you will, or flip it, right? I can show you where that came from, but anyway, what we're gonna do now, if we go down to the bottom part, I want you to write out 3 primary trig ratios and the 3 reciprocal trig ratios. Okay, lessons are up at the front. Okay, so what I want is I'll have the primary trig ratios here. Okay, if you're just getting here too, you need a late slip because I've already done attendance, so you gotta go deal with that. You're not here, according to Ruth. Okay. So the primary trig ratios are going to be sine, and we're in reference to angle theta down here in the bottom left, so angle A. You call it sine A or sine theta, whatever. Okay, I need the cosine of theta, and I need the tangent of theta. So using SOHCAHTOA, I know sine is what? I know sine, you guys gotta figure this out. Opposite over hypotenuse. No, I don't need that yet. Just give me a sec. Cosine is gonna be adjacent over hypotenuse. Tangent's going to be opposite over adjacent. Okay, so what I need to do is just, let's go back to our triangle and just label the side lengths accordingly so that I don't make any silly mistakes doing the trig ratios. So the last thing I think you want to do is get like all I'm asking you for, I'm not asking for any answers, just asking you to write one number over top of another one in relation to a particular angle. That's it. I don't need any answers here. Okay, your answer is the fraction that corresponds with the triangle. So I'm standing here at theta. That's going to be opposite. That's going to be adjacent. And this is going to be hypotenuse. Does everyone agree? Okay, so just label, like all you're doing is putting in the numbers for opposite, hypotenuse, adjacent. That's it. Where you've identified them to be based on SOHCAHTOA. Right, so opposite in this question is going to be 3 over 5. Cosine is going to be 4 over 5. And tangent is going to be 3 over 4. Is everybody okay? Okay, so the reciprocal trig ratios. I would start, like, the only two you're going to have to really memorize, there's going to be cosecant and secant. Right? So the goal here is, like, you're going to be matching these up. Right? Because it's just a reciprocal of the ratio that you have there. So let's start with cotangent, because I think it's got tangent in the name. You can't mess that one up. So cotangent theta is just going to be the 3/4 reciprocated. So the trig ratio for cotangent is going to be 4/3. Let me see that. Okay, and then the hard part maybe is just remembering cosecant versus secant. Because anyway, you just have to come up with your own way of remembering it. Okay, so cosecant. It's kind of opposite of what you think it is, actually, because it sounds like cosecant sounds like cos, but it's not. Sine. So cosecant is 5/3. And secant, nope, sorry, include the angle. Cosecant theta. It's important to put the theta there because it's relative to theta and not the other angle phi or something else. Right? So you got to put where you are referencing in your trig ratio. Otherwise, how am I supposed to know that it's this angle instead of this one? So you put A, B, put whatever in after your trig function, right? So the secant is going to be 5/4. Okay, that is a question on your test. 3 marks. I'll give you a triangle, you got to come up with the ratios. That's all I'm looking for. Everybody okay? 3 marks on your test. Okay, turn the page over if you're good. Okay, so this might require, well, you're definitely going to need a calculator still to do this work. Okay, what I'm interested in here is solving for the variables. So what we can do right off the bat is get y. Right, so if I call this, this is going to be the hypotenuse, and then this can be whatever, doesn't matter. If I'm standing here at this angle, that's going to make this opposite, this adjacent. Okay, but the first thing I'm going to do is get the side length. And what do we have at our disposal to find side lengths? In a right angle triangle specifically, Dylan. We have Pythagorean theorem. And what Pythagorean theorem says is, when I sum the square of the two side lengths, like the legs of the triangle, it gives you the hypotenuse squared. right? So, and that's just fancy words for remember, I'm using the capital letters to represent the angles and the lowercase letters to represent the side lengths. Okay, and so in this particular triangle, Pythagorean theorem is going to say z squared plus x squared a more familiar version of that would be a squared plus b squared is equal to c squared. Okay, it's just specific to how they've labeled this triangle. It's z squared plus x squared is equal to y squared. Okay, so you just put your numbers in. So z is going to be 5, so we get 5 squared plus 8 squared is equal to y squared. So we get 25 plus 64. It's 25 and 64. 89. So I need 89. It's going to be y squared. Square root both sides. What's y?
9.43.
9.43. Do I need a negative answer for y? So remember, we square rooted both sides, so technically I got to do a plus minus. It doesn't change from quadratics because there is 2 answers that satisfy this, but you can't have a negative side length, so that doesn't make any sense. So typically with a trig, like the actual applicability of stuff, you can't have a negative side length. All right, so you really only just, sorry, it was 9.81. Is that right?
9.43.
4.3, sorry. 4.3 what?
4.3398.
No, centimeter. Centimeter squared?
Centimeters.
Which one is it? Just centimeters. So it's a length. It's a measurement of length. Centimeters squared would be a measurement of area. And what's centimeters cubed? It's volume because it's 3-dimensional. It's 3-dimensional, you get a cubed. 2-dimensional objects, areas, have an exponent of 2. 1-dimensional things, like a length, like a side length, 1 dimension, the exponent's 1 on centimeters.
What about 4?
That would include time, buddy.
What?
What's your 4th dimension? Okay, are we done? What else do we need?
Angle time.
I need the angles. So you're stuck having to use your trig ratios to find one of them, but you could use them to find both, but there's a smarter way to find the last angle, which I think you all know. So, we'll solve for angle x, because that's how our triangle is labeled, right? How do you want, this is maybe an important question. Which of your 3 trig ratios do you want to use? Dylan?
10.
Tangent. Why did you pick tangent versus the other 2? Because the other 2 will give you an answer.
This is kind of cheating because we just found the hypotenuse.
Well, we found that. Well, it's not cheating.
Yeah, well, yeah,
It's we found the hypotenuse, but let's pretend for a sec. Let's imagine that you did something silly and had this number wrong. So probably not going to happen too many times, but it could happen depending on, I don't know, test situation, whatever. Who knows? Do you want to take the risk of using a number that you've calculated when you have enough information to do it without having to use said number? No. So this information has been provided to you in the question, and there's a way to use that information, which is way more reliable than using a number that you've calculated, like the hypotenuse. So the 2 trig ratios that involve the hypotenuse are sine and cosine. So just for the sake of comfort, I'm not going to use those 2 because they involve the number that I've calculated. Right? And so I'm going to use tangent. So the tan of angle x is going to equal opposite over adjacent. What is it? This is an important part because somebody at some point is going to ask me, when do I use tan inverse or tan to the -1, and when do I use tangent? First of all, why don't you give me a number for 8.5? I would prefer you not to round it, so use, is it just 1.6? Right on? Okay. So I would prefer that you actually use the fractions here, because if you start rounding, your angles are going to get a little bit off, right? So whatever the fraction is, use it, the ratio, right? So I'm going to get tangent. This is a nice question because we're just going to have 1.6 right on, so there's no rounding error, okay? And this is a nice question now because I can communicate something with you. What am I looking for in terms of an answer, Reese? Say that again?
The angle.
Yeah, and the angle is represented by what variable in the question?
X.
X. So I'm looking for X. And just like all the other work that you've done ever, when you're looking for one particular thing, what do you usually do?
Get it by itself.
You get it by itself. You isolate it. How do I isolate X from what I have on the board right now? So whether or not you realize it, tangent is multiplied by X in this particular situation. So if I'm multiplying by tan, what am I allowed to do to get rid of it? Divide by tangent. So if I divide both sides by tan, I get X is going to equal 1.6 divided by tan. Now, a lot of you are going to look at that and go, I'm not happy with that because I've never seen that before. Would everyone agree? That's definitely not the way that you've seen it before, but it is the same thing as what you are familiar with. You just don't know it, which is why we're doing this. I'm going to ask you another question. What's the exponent on tangent right now?
1.
Just 1. Everyone agree? I can put an exponent on 1 on anything, right? So the exponent on tangent right now is 1. What am I allowed to do with exponents? Or things with exponents on them? You can move them from the numerator to the denominator or vice versa and make the exponent negative. So X is going to equal tan inverse of 1.6. I show this so that it eliminates the question that people usually have of when do I use tan inverse and when do I just use tangent? You use tan inverse when you're looking for the angle. So to access that button, you need to go second function tangent. You should see it sitting above on the actual hard plastic of the calculator. To access all that stuff above the buttons, you got to hit shift or second function or whatever it is. So you just type it in as you see it. Jacob?
Is it like the tan with the -1 at the exponent?
Tan to the -1 of the exponent. Yeah, yeah. Just as you see it there. So what's the answer?
58.
58 degrees, everyone agree? We all land on 58?
57.99.
Rounding, Jake. You're gonna kill someone.
You're gonna kill someone. Owen, don't round.
Not me.
Oh, Jacob, don't. Anyway.
On your bridge, check the Jake, they're gonna die. 57.99.
Okay, when I say solve a triangle, what do you think that means? How many pieces of information are on a triangle? Dylan? 6. So you better have 6 pieces of information on your triangle. How many do I have right now? I have 5. I need one more. The last thing I need is this angle Z. Now, do you want to do all this work again?
No.
Why?
It takes too long.
It does take a bit of time. Okay, but there's a fundamental rule with triangles, Levi.
All angles are equal to 180.
Yeah, when you sum up the angles of a triangle, any triangle, doesn't have to be right angled, interior angles, they have to add to 180 degrees, which means X plus Y plus Z has to equal 180. You know Y is 90, and you just found X. So it's 58 plus 90 plus Z. What's Z? 92? 32. That's going to save you like 2 minutes on a test, right? Just using that little rule instead of having to do SOHCAHTOA again. Is everyone good? Okay, we'll do the second one and then I'll let you work on some questions. Ricky?
On a test, will you want us to write like dividing by 10 and then
No. I just did that. I just did that to show you because inevitably somebody's going to ask me, when do I use tan inverse? That subsides as we go through the grades a little bit. The kids figure that out. But that's one of those things that I never really put together for myself as a kid. It's just like this idea that like some of the exponent rules that we have translate into other parts of math, and this would be one of those areas where like that -1 actually means something, right? And that's just to show where it came from. Okay, so let's do the last one because this last one's a little bit different too. Okay. What would you get? What would you solve for first? No, I would get the angle Y first, right? So, Y. What is it going to be?
52.
So angle Y should be equal to the 180 minus 90 minus the 38, right? So angle Y should be what'd you say, Dylan? 52?
Yeah.
Okay. So 52 degrees. And now here's the tricky bit, because we can't use Pythagorean theorem right now, can we? I don't have two side lengths, so I can use Pythagorean theorem, which means these trig ratios that we've been looking at, maybe you have a misconception that they can only be used to solve for angles. You can use them to solve for side lengths too. Okay, so here's my angle of interest. I'm standing here at 38 degrees. I look across and see what? No, not the answer I'm looking for. Obviously, I know it's Z. Thank you. No. Okay. Opposite, as we've done, which means this is hypotenuse, and this must be adjacent by default. So what do you want to solve for, Z or X? It's not a life and death decision. You just pick one.
Did I not just pick one?
It took a little bit of time. Okay, if we're going to solve for Z, let's ignore this is here. I'm not interested in it right now. We've made the decision to solve for Z. So, if I ignore the adjacent side length and I write out if I ignore adjacent right now, if that's the decision that we have made, that means any of the ratios that have an A in it, I'm not going to use. Everyone agree? Which only leaves one option. What is it? Sine. So I'm going to write the sine of theta is going to equal opposite over hypotenuse. And then I'm going to fill in the information that I know. What information do I know? 20 for what? Sine 20? Is this what you mean? No, so be more specific. 20 goes where? 20 is the hypotenuse, and 38 is the angle. Angle is going to go in place of the theta. Okay? So sine of 38 has to equal z over 38. Sorry, 20. There you go. How do I get z by itself, Levi? Multiply both sides by 20. So z is going to equal 20 sine. This is how you would, well, I type it in your calculator like that. Let me get a number.
12.313.
What is it?
12.313.
Okay. Now I'm going to find adjacent. Am I going to do that again? What's easier than SOHCAHTOA? Use Pythagorean theorem. Now, just careful with it this time. Pythagorean theorem says what's C? C is 20. And I just found one of the other side lengths. I don't know. We get 12.3. We're going to look for A. Should have 400 minus 140. I don't know. 140. I'm going to guess 140. I have no idea. 146? What?
What?
What's 12.3 squared? That was, what is it?
151.29.
Yeah, there's no way it's what you said. What is it, Jacob?
151.
I was,
29.
all right, that's good.
Oh, I was talking about when you minus it.
Oh, yeah. Listen to the question I ask.
My bad.
That's okay. I know it's your bad, not my bad. I asked the question. You gave the
It's on
wrong
me.
answer. It's on me. Okay, what's that answer? Ricky?
15.87.
After you square root it?
Yeah.
What's the answer before you square root it?
Oh, 248.7.
And so you said 50 point what, sorry?
15.8.
Oh, 15, sorry. Centimeters. Centimeters. Okay. That's that.